Hey everybody, welcome back to the channel. We've got a little bit of a hiccup with our audio, but don't worry, that's going to clear up in just a minute here. In the meantime, let me tell you about today's project. I want to build a drive dog that I can use both in the lathe and in the tool and cutter grinder. So I've got this old arbor here from the tool and cutter grinder, and the threads are shot. One of the reasons I want the drive dog is because I'm going to grind this taper on, and I find that the tool and cutter grinder is a much easier machine to create an accurate taper and also to make, small little changes on the fly. So that's the reason for it. The beautiful thing about cutting a taper in the tool and cutter grinder is your centers are always in line with each other, whereas on the lathe, if you were to offset your tailstock to cut an angle, all of a sudden your centers aren't in line with each other anymore, and so your live and dead centers aren't fitting in the center holes properly, and that can just lead to all kinds of problems. Another fact is that I don't have enough travel in my compound rest to cut that entire taper in one setup, and cutting that taper in one setup is imperative if you want it to work properly. I do not have a taper attachment for this lathe, and so that's another option that's, well, it's not available to me. So again, the tool and cutter grinder is going to be by far the most accurate, and it's going to be the fastest way to do this. So as many of our projects do, we're starting off here in the bandsaw. So I'm just slabbing off a big piece of it's hot rolled mild steel. I'm going to cut it oversized in the bandsaw here, and then we're going to proceed to the milling machine and get rid of all the mill scale and square it up. So that cut's done. Let's move over to the milling machine now. So I figured I'd spare you guys the agony of having to watch this entire setup. I'm just putting the finishing touches on it here now, making sure my vise is all dialed in, and then we can actually, get cutting here, get something a little more interesting going. The reason it's important that I dial this vise in is because there's two holes I have to drill in this thing, and I want them to be in line, and dialing this vise in will help me with that.
There's the first side all cleaned up. I'm just going to give that a little lick with a file, and then we'll flip it over and do the other side. I'm just taking a minimum skim off this side. I want to get the thing cleaned up, measure it, see if I have equal measurement on all four corners, and then we'll bring it to the finished size. There it is, all cleaned up and to size. So I'm going to give that a quick deburr, and then we'll clean everything up. We'll flip it over and we'll start. First, I'm going to minimum skim one of these faces just to give us, something clean, get the mill scale off it, and then I'm going to go to the other face and we're going to bring it to the finished size. I've got a couple of these 3/8 square high-speed steel tool bits that I'm going to be using as parallels in here, so that the surface is nice and above my vise, so I don't run the risk of running into my vise with my end mill. This is my last pass on side one, and then we'll deburr it, clean it all up, flip it over, and start working on the other side where we're going to bring it to its finished size. This is our fourth surface now. Start that up. Got a ways to go here. Now, this cutter is 11/16 diameter. I'm taking 50 thou cuts. So there'll be two entire passes over the whole surface at 50 thou, and then a cleanup pass at 25 thou. And I think this is probably about the biggest cut this machine's going to want to take. an 11/16 diameter cutter, taking a 50 thou deep cut. That's the four sides finished. Now I'm going to make a setup and I'm going to clean up these ends. And I don't think the milling machine's going to like doing that very much, so I'm going to tighten everything up. I'm going to retract this in some. I'm going to drop this down some, get everything short and tight. Here's end number one, all cleaned up, and the machine actually didn't mind that as much as I thought it would. Of course, I was taking pretty light cuts because, I mean, it's a pretty light machine. I didn't get a lot of video of that because the light isn't great. It would have been tough for you guys to see what I was doing, but I'm going to move to the other side now, and it should be better for getting some videos. So that's working pretty well. I'm only taking a 15 thou depth of cut, but it's across that whole 7/8 of an inch height, and it feels like that's about the most the machine wants to do. So I'll just take a few cuts till I get down to my finished dimension. So here is our block, all squared up, machined on all of its sides and to the dimension we want it. I'm going to lay this out now for the rest of the designs that we're cutting into this thing. Here it is all laid out. I made a couple little changes on the fly. I didn't think I needed so much meat over here, so I thinned that out. And yeah, this is just going to be a little less weight, a little less unnecessary material, and it's going to be a little bit more milling. Here's side one. It's I've got it. I've finished all the milling, and I've got this all nice and deburred. So I'm going to flip it over and start working on side number two. Right now, I'm cutting out this material here on side number two. So the other side already looks like this, and the surface of this right now is here, and I'm working on this, and then later I'll come work on this. Now I'm just cleaning up the back because I've been running lengthwise, and of course the back of my cuts is a radius. And I only have one more cut to go downwards, so I'm cleaning up the back surface right now. I've got one cut to go. I'm just measuring to see exactly how we're looking here. And 53 thou to go. Here's where we're at so far. Next thing I'm going to want to do is put these 45-degree angles on these corners here and just mill these corners off at 45 degrees. So that's the next setup. I'm just getting this set up now to cut these 45-degree angles here. pretty darn close. Giving this a quick deburr so it's the vise is grabbing on, not a burr. I've got my 4 angles done there now. Reasonably happy with it, with the slight exception of this. My table moved on me, should have had it locked, didn't, put a little nick in there. So I tore my last setup down. I figured nobody wants to sit and watch that, so I just did that off camera. And I need a lot more room now, so I've taken that riser block out of here because I'm going to be using my drill chuck, which eats up a lot more space. And so I'm just getting dialed back in here. My next step is to put these 2 holes in. The hole for the workpiece and the hole where the drive lug is going to screw in. So I've got those holes laid out here. I'm just going to get centered up now that I'm all dialed in, and we're going to start drilling out those holes. So I'm going to be drilling through this thing. I don't want to drill into my vise ways, so I'm spacing it up a good bit there so I can pop through the drill and not worry about damaging my vise. I've got this center drilled now, and I'm going to go through with a smaller drill, and then I'm going to go through with my tap hole drill because I plan on threading this hole after for the little stick that's going to stick out to drive this thing. Okay, I left my table locked in place. That way I know this tap is starting bang on center. This hole is going to get the best chance possible to be nice and straight. That's about as far as I can go with this little chuck. I have to put the tap handle in there now. This is just a piece of hot rolled mild steel plate, so it taps reasonably well. I ran the taper tap through there first, and I don't want to hit the bottom of my vise with the long, the taper tap. A lot would have to go through before the hole's complete, so I'm switching to a bottoming tap just to clean up that last little bit. Put my center drill back in here. I'm going to move to my bigger hole, and I'll show you on the sketch here. So we just drilled and tapped this hole here, and now we're moving down to here, and we're putting this bigger hole in. This is just a little over 5/8 now, so I'm just stepping it up at a bit of time. After this, I'm going right to 1 inch, and I do want this bore to be nice and true so that it gives even pressure on the work pieces that I'm clamping it onto. So I'm going to attempt, after I drill the 1 inch hole, to bore the whole works out and see if I can get a nice, straight, true, clean hole. And here's my 1 inch drill. I actually ground this down. It was a bigger diameter drill bit. I think it was 1 1/4 inch, 1 1/8, something like that. But I needed a 1 inch drill one time, so I ground the lands on it here, and then I put a bunch of relief behind the lands just so it would clear. And now it's a 1 inch drill. That wasn't so bad. This is my offset boring head kit. It came with, of course, all these boring bars, and I've used it a couple times so far, and it works quite well. The one thing I wonder if it's not a little sketchy, though, is in between this arbor and the offset head itself, there's a 7/16 thread holding the two together. Now, there's also a big bearing surface here that, spreads that load out, but I just wonder if 7/16 isn't a bit of a small thread to be doing all that work. I might have gone with a 1 inch thread or something, but this is what it is, so this is what we're gonna work with. Taking a real light finish pass here. The machine was jumping all around on that first pass with the bigger cut, and I want a nice clean finish here so it puts even pressure on my workpiece when I'm actually using this in the lathe or the tool cutter grinder. This feels and sounds like it's working a lot better. that's it. I'm gonna pull that, I'm gonna back it off. I'm happy with that hole, happy enough with that hole. And that's the end of our milling actually, so I'm going to tear this whole setup down and get this thing set back up as a lathe. And then there's some lathe work I want to do to this thing. I just flipped the part over and it's not dialed in or anything. I'm just going to use my deburring tool here to get this massive burr off the back side of the hole. This is actually something I made back in my early apprenticeship days because the little stupid plastic handles you get with deburring tools kept crumbling in my hand, so I made this steel one. See how nice that works?
Very nice.
Well, I did a bunch of the boring stuff just off camera. I cleaned it up-ish enough and got the forge on chuck on, swung the mill head out of the way. I've got all the gearboxes switched back over to lathe. I have my compound rest sitting there. And so now I'm going to take my piece. So now what I'm getting ready to do is I have to drill and tap a hole here. Eventually this bolt will go in here and clamp down on the workpiece. And I want to put a radius on all these sharp edges here. I want the radius to kind of come along, come up here, come along, come down here, and then come back out here, and then probably put a little bit more in here. Just for fun. It'll just really clean it up, make it look like a, you know, something someone gave a crap about building. So my dial just broke. This screw, this funniest thing I've ever seen. This screw had a plastic injection molded knob on it where the countersunk head was all that held the knob to the screw, and the Phillips drive was all that was driving the plastic knob and screw to clamp this thing down. It's the silliest thing I've ever seen. It was hilarious.
Okay, well, you hated this one anyway.
Yeah.
Time for a new one.
I need a dial, definitely. Well, I'm nice and dialed in here. It's a little odd with square things because you kind of have to, you know, be on center and find the middle of it all. But if I start here at this side and I go around to the opposite side, pretty darn close to zero. Now I come to this opposing side, not an opposing side, another pair of sides. And I find what appears to want to be zero here. And then I come around to this side and I'm still pretty good. Now when I travel lengthwise on this surface, I stay pretty good. Now I'm going to travel lengthwise on this surface. And that's pretty good until it hit the hole. That's pretty good. So I'm ready to go. I'm going to be super careful and gentle when I put this center hole in here because I'm not holding on by a lot. If you look over here, I mean, I might have 1/4 of an inch that I'm hanging on by. So there's an awful lot sticking out. I'd never dream of like machining out here without having a center in here. Or if I did, I sure as heck would be out of the way. Did a little more setup off camera, just so I don't bore you guys to tears, but I'm ready to drill my center hole now. The center drill is going to exert such little pressure that I have no fears of that thing jumping out of there. As a matter of fact, once the center drills into it a bit, it'll actually be offering support to the workpiece. See how we look.
That's good.
Yeah, it's actually mint. If you look at this little bit of angle left here, compared to that side?
Much better.
Yeah, I'm happy with that. Okay, so we're gonna bring that around some more. I want that to go farther along here, and then we'll start blending this side in and work our way up here. So I'm happy with that. That's what I wanted for the end. Now I'm going to start working my way just down this side and then eventually up over here and down here with that same radius idea.